Hello, good afternoon. Welcome to the online webinar. My name is TJ Kim from MIDAS Singapore. Before we getting started, if anyone can see the screen properly, please raise your hand using GoToWebinar function. So if you have any question during the webinar, you can just write down the question in the question box. Then we will take care of the question. So today's webinar purpose is to communicate you better techniques of performing steel structure design in MIDAS Gen. This webinar will help you in learning quicker method of performing various jobs in MIDAS Gen. In the presentation, we will model a steel structure, generate imperfection load, perform steel design, design steel connection, and we will also design foundation. The entire sequence of steps will be automated. So first question is, what is MIDAS Gen? So MIDAS Gen is an integrated solution for structural engineering analysis and design. And it is one of our MIDAS family programs, such as geotechnical, bridge, or other things. We can design for steel and concrete together in MIDAS Gen itself, and various member types such as RC frame, RC slab, raft footing, steel frame, and cold form steel. But today we are going to focus on steel part. And using MIDAS Gen, we can start from modeling, loading, analysis, design, report, unit design using Design Plus, and drawing. As you see in this example structure, there are various member types, including steel truss part in the middle. Along with MIDAS Gen, the package includes Design Plus and Drawing Program. Design Plus is used for unit member design of isolated footing or steel bolt connection and so on. MIDAS D-Shop or Drawing is used for generating structural drawing for the model. These are the structure types available in MIDAS Gen. Not only for the building structures, but also many kinds of general structures can be handled in MIDAS Gen. Apart from that, all kinds of steel structures can be handled using MIDAS Gen as well. From the small steel storage structures to large steel plant and infrastructures, MIDAS Gen is widely used in steel structure industry. In Singapore, MIDAS Gen has been used over 5 years to design numerous steel projects. Some companies are using MIDAS Gen better than technique support in MIDAS. Even in these days in China, a lot of ongoing huge steel projects for plant and infrastructures are being carried using MIDAS program. MIDAS Gen is already well known for steel structure design in worldwide. I'll be quick for use interface part. So this is the interface of MIDAS Gen. So as you see, this is 2017 version, latest version. And in MIDAS Gen, we can actually work on different working environment. For example, as you see here in the image, we can actually open the different viewpoint mode. So you can work on the isometric 3D view and from view to 2D from view and top view together. So those all three viewpoint is affected each other. So if you change some models or if you change some data in any other mode, then it will be simultaneously changed at the same time. And also various view mode are available in MIDAS. So this is normal wireframe view mode. You can simply work on the 1.9, or you can even see the hidden section of the structure, and you can see the human perspective view mode. And also you can see the different color as different section properties or material properties. And even you can activate your partial part of the structure, and you can work on different mode. And in the result part, it will show the deflection in 3D mode, or you can even see the contour for the result. So for the compatibility, actually in MIDAS Design you can import from AutoCAD DXF file, or if you have the stat profile or ETABS model file, you can import from that model file to MIDAS Design directly. And for Tekla or Revit, the model file, you can actually import from Revit 2017 version. So recently we added the 17 version Revit interface. So if you have the model file in Revit, you can directly import from Revit to MIDAS Design. Not only for geometry of the model, but also you can import the loading or boundary condition from Revit model file to MIDAS Design. So for the modeling part, the simple things I will show in the demonstration. So here I have the MIDAS Design, and I opened already a new project file. So here the first thing I want to show is the starting of the modeling. So as I explained in the presentation, we can actually start by importing some model file from this import option. So here, as you see, we can import AutoCAD DXF file or SAP 2000 model file or stat profile. And as I said, Tekla structure or Revit model file, you can convert to MIDAS MGT file, and you can directly import using this function. And or you can even start from the scratch in MIDAS Design itself. So before going to the modeling part, I also show you the properties for material and section properties. So here in the material properties, we can open the materials. So in the property, we can click on add. So here you can use the steel or concrete material, and there are various standards you can use. So for example, American code or BS material and Eurocode material. And also for Singapore, we have BC1 material here. So here BC1 class 1 steel, or you can also use class 2 steel here. So we can choose class 1 steel material, and you can choose the grade of the steel. So after we choose the grade, program will directly show you the properties of the material. And also for sections, we have various section types. So here we have various section shapes, and then for the standard, you can even use various countries' product type. So we can use American or BS, and then Korean, Japanese, but we also have SS, which means Singapore standard. So this one we added for Singapore section size. We refer the continental steel size. So for continental steel size, we can use not only for I section, but also you can use for box section SS standard, or you can even use the cold form steel section. So you can use various section shape in continental steel size. So for example, if I choose normal I section, we can choose in the section name here. And in here, the program directly calculate the section properties. So when we start the modeling in the scratch, we can use various modeling feature in MIDAS Gen. So creating nodes or create elements, and then we can use copy option or extrude function. And moreover, in here, we can use the various wizard for modeling. So I show you in the presentation some example model. So if I model those kind of steel structures, we can use the frame wizard many times. So in this, using this wizard, we can just input the distance and then coordination. And then we can add the coordinate. And then we can go to Edit tab. And we can directly choose the steel material and section size, and we can generate the frames. And Insert tab, we can insert these sections in this work model view. So we can directly generate our steel frame in our model view directly. So this one, if I use this one without importing from some other Beijing model file, we can even start from the scratch the Beijing modelings. So if we have this frame, for making the columns, we can directly select some nodes. And then we can use various modeling feature here. For example, if I use for extrude function to generate the columns, then we can directly generate the columns on that node. And even for the truss part of this steel structure, we can just go to the structure and then base structures. So we can use truss wizard. So using this wizard, we can simply model our structures. So we can just choose the type of the truss and then diagonal axis, diagonal direction, and then number of panels we can input, and then distance. So we can also make it all the dimension here, as you see in the figure. And then we can use symmetric, and we can add the vertical or end vertical truss. And then we can insert the making the position and click apply. We can apply the truss. So those all sections we can even change during the modeling. So simply we can just input the data directly here in wizard. We can just model our steel structure in MIDAS Gen from the scratch. So sometimes it takes more time if I modify in other program. So we can directly start from the scratch if we get used to the software. So for the loading type, I will show you some examples using the existing model. So I open new model file. So in Singapore, we have many projects like this kind. So if you see, this part is RC here, and then this part is steel. So there is a RC office structure part here, and then we have steel factory part beside of the RC. So this kind of structure, I already show you that we can generate the frame, and we can generate the columns, and we can generate the truss type using some wizard. So modeling this kind of structure is not that difficult in MIDAS Gen. So now the loading, if I show you some loading type here, so even you can use various load types. So for example, static loads or dynamic load, and dynamic loads for response spectrum seismic, or settlement for imperfection loading. And you can even use the temperature, pre-stress, or construction sequence, moving node. Various load type is available in MIDAS Gen. And for nodal load, also available, the basic loading for nodal load or uniform beam load. You can even simply apply your loading, all kinds of loading in your model. So for demonstration, I will show you the lateral load auto generation function in this webinar. So if I go to wind load, so we can add the wind load. So as you know already in Eurocode, wind load generate the wind load is quite tedious job. So here in MIDAS, we can just choose the code as Eurocode and then Singapore National Annex. Then when we choose Singapore National Annex, all the parameters will be defined as a Singapore National Annex. We can simply choose the structure type 1 or 2, and then all other basic parameters already defined as Singapore National Annex. And building height also calculated by the program, and even you can also change. And there is a one button, parameters for mean wind velocity. So this one is in Eurocode. Sometimes in some criteria you need to consider these parameters for mean wind velocity VM value. So I just show you some images. So here this image is from Eurocode. So if our orography type is these cliffs or this type of hills, based on these basic parameters, we need to consider various formula in here. So in MIDAS Gen, we can actually check on the option consider orographic effects, and then you can choose the orography type, cliffs or hills. And then based on just simple parameters, program consider those many formulas by automatically. And even some other two effects. One is neighboring high-rise structure effect. So if your structure located nearby high-rise structure, then we need to consider those high-rise structure effect when we calculate the mean wind velocity. And similarly for raising of displacement height. So if our structure is here and there is another other structures nearby my structure, based on this effect, we need to also calculate some formula in Eurocode. So those all effect, we can just simply check on this option, and then we can input the data, like just simple data, height or slope, upwind slope or downwind slope, that's it. And then program will consider. And even for structural factor, this CSCD value, many other programs ask you to input by manually this value. We can even use value 1 in some criteria, but many times we need to calculate by ourselves this CSCD value. So in MIDAS, it provides automatic function as well. So based on information, your structure information, and then we can just click calculate button. Then program will give you the final structure factor value here. So we can just click OK to input this value in generating the wind load. And without the analysis, we can even see the wind load profile. So you can see story force or story shear and overturning moment. And in tabular format and also in the figure. And even program will gives you the calculation process in text format. So when you want to see the process of calculating this, you can even referring this text format window load calculation sheet. Okay. So this is the window load auto-generate function. And even we have the seismic load auto-generate functions, but this one maybe I'll skip because for the steel structure we usually not consider the seismic, but you can even automatically generate this static seismic load and also response spectrum seismic load in Singapore National Annex. Okay, so also now I will show you some other lateral load for imperfection load. So in Eurocode, so in Eurocode we need to consider the imperfection load as well. So as you know, imperfection load is quite important in Eurocode concept. So in Eurocode imperfection, we need to consider the equivalent horizontal load on the structure. So when you calculate this equivalent horizontal load, HL value, we need to consider V for the vertical load for structure and pi. So this pi, we need to consider also pi 0 and alpha H and alpha M. Pi 0 is just specific value, and alpha H is we can easily get if we know the H height of these stories. But the problem is alpha M. So alpha M is various based on this M value. M value is the number of columns in a row. So based on the number of columns of your structure, each stories, then this alpha M value is various. So because of this alpha M, we need to consider some Excel. We need to calculate in the Excel file by ourselves. So we need to consider the phi value, and then we also apply the imperfection load based on this phi. So this is what we have to do, what we have to calculate in Excel file for imperfection load in Eurocode. So in MIDAS Gen, how we can consider this effect in MIDAS Gen. So if we go to the settlement and miscellaneous load in the load tab, now we can see the new feature imperfection button. So here in the imperfection, we have two buttons. One is imperfection data and one is create imperfection load. So I will show you imperfection load first. So using this dialog, we can actually generate the imperfection load case automatically. So we can input the direction we can input the name with the direction, and then we can choose the vertical load. So actually imperfection load, we need to consider the vertical load to generate the horizontal equivalent horizontal force. So now we can choose dead load, global X direction we can add, and live load, global X direction we can add. So we have two load case for dead and live load global X direction. And we can change the name for Y direction. We can also give dead load for Y direction and live load for Y direction. So now as you can see, we have four load cases generated here. Now in this model, we have only two cases of the vertical load. That's why I have four. So we can generate more load case in imperfection load. Now what we have to do, we can just click this create imperfection load button. Then program actually generate by itself and so it actually consider the pi value automatically by the program. So all the phi value is calculated by the program based on this number of columns. Okay, so it shows some analysis time, but it actually calculates the load. So if you see here, I just changed the mode. So as you can see, the load had been generated by the program. So as you see, the load for each load case has been generated, and then this one you can see all the load had been applied on the top of the column, and then also for the lateral direction. And here's the thing I need to explain more. So for example, if I show you some story names, so actually as I said at the first time, this part is steel and this part is RC. This part is steel factory and this part is RC frame. So in this kind of structure type, the imperfection we need to actually consider different story data. Because here, as you see, this story for steel factory and this story data for RC office building is different. So if this story data is different, then the imperfection load have to be applied differently. Then how we can consider these different story modules in MIDAS Gen? We can actually go to story. So in MIDAS, we can consider different story data for different structural part. So as you see here in this data table, I defined RC part and story and base part for steel. So I separately generate for RC and steel story data here. So in program, actually it consider those two different stories for the phi value differently. So as I show you, if I show you the load imperfection, the first option, imperfection data, this is the what program used for the parameters. So if you see here the height and number of columns, so this one, as I show you in the presentation, this one we need to use for the calculating this imperfection load. So as you see, the module and story is different for RC and steel part, and then there is a height and different number of columns for different stories. So program actually consider those different story. And this user coefficient part is when you want to use your own coefficient for this structure, you can actually click on this user button. Then you can input your own coefficient. So even if this now is 0 value, the program actually calculate by itself the phi value, but this option is when you want to use your own coefficient phi value. So this is that dialog box. So now we're generating the loading. So then how about the load combination? So in the load combination, also we can consider the imperfection load. So first, if I explaining the base general things of load combination, in MIDAS Gen, we can automatically generate the load combination as per Eurocode. So here there's a button, auto generation. So if I go this button, then we can see this dialog, this type of dialog box. So here we can choose design code, Eurocode, and national annex, Singapore national annex. And there's also some other options we can consider for generating load combination. And as you know, in the Eurocode, we need to consider the variable action. So variable action also considered when you generate the load combination. And if you want to change the variable action, you can also open this variable action data box. And also recently, we added this consider effect imperfection load. So you can just check on consider imperfection load, and here if you want to change or if you want to see the data of the load case, then you can even click on this button, set load case imperfection direction. So I will just delete the previous one. So let's try to generate the using the auto generation. Let's try to generate the load combination. So we can just check on this option, consider imperfection load. These are for seismic action, so we can just leave it. So we can click on OK, then program generate all the load combination. So we can even see in this format, or we can also see the X table format. So as you see here, imperfection dead load and live load for X, Y direction has been generated by the program. So even here, if you see dead load for load combination factor 1.35 has been applied, and also live load 1.5 has been applied. And for positive and negative direction, all had been generated by the program. And using this kind of table format, you can directly input your load combination data, or you can even use the copy paste function. You can just Ctrl+C or Ctrl+V. So also table format is very useful, and even if you have the Excel format of this data, you can directly import from Excel to here, MIDAS Gen. Okay, so this is the load combination. And I just run the analysis, and then I will show you some result of this imperfection load as well. So as I explained in the presentation, here after this statement, we also have some statement in the imperfection that if horizontal force, if lateral force is bigger than 15% of the total vertical load, then the notional horizontal load can be ignored. So this statement is in Eurocode. Because of this, so if the lateral force is higher than this, then we don't need to consider the imperfection. So in MIDAS, after you run the analysis, if I go to result table here, imperfection. So at the last, we can see imperfection table result. We can go here. So we can choose the load combination which we want to see. And as you see in the table, we can see the horizontal force for X and Y direction, and then we can see the total axial force, and there's also 15% of axial force. So program actually compare this horizontal force and 15% axial force, and it will give you the result that if whether we need to check imperfection or not. So as you see here, or load combination, it is required to check imperfection. So this kind of result table you can also get from this latest version. Okay, and now we will move on to design for steel. So before getting started to demonstrate, here in MIDAS Gen, the special feature is auto calculate of effective length vector. So in some other programs, when we design for steel, we need to input the effective length vector by manually. But using MIDAS Gen, actually there's a option that auto calculate effective length vectors. So if we check on these options, then program actually calculate the effective length vector automatically based on different joint condition. Even So even if you want to input your effective length vector, your own effective length vector is also available. But by the program, automatically, we can also calculate the effective length vector. So as you see in the image, the based on different joint condition, program actually consider the different effective length vector. And also the member definition of the for the design. So if we have this sub beam here in this kind of structure, in the design process, we need to consider this main beam as one member. But since using the program, this is two members, so we need to actually define this as the one member in design. So in MIDAS Gen, we also have the automatic function to detect this kind of two member in one combined member in design process. So these are the result types we can get from MIDAS Gen. So I will show you in the demonstration. So after we run the analysis, we are ready to do the design. So, but for the design, we need to actually generating load combination first. Then we can do the design. So now let's do the design part. So actually, recently we also added the torsion design as per Eurocode 3 and Eurocode 2. So for RC or for steel, we can do the torsion. We can have the torsion design data as well. So this is steel structure webinar. So I added only steel torsion design slide. So torsion design is performed automatically with member design, and the procedure is as follows. So we can consider Saint Bernard torsional constant, and also torsional section modulus, and cross-sectional torsion and shear resistance, and flexural by taking into account reduction factor, and also yield criterion for the elastic verification. So as you see here, this is the table format result we can get from steel design result. So we have additional column. This is T, so this is torsion design result. And even in the report, we can see the torsion strength, and then detail report, we can also see the torsion resistance and shear. So let's see in the design. I will just select some specific member to reduce the time. So if you don't select anything, then program will run the design for whole steel part. But in order to reduce the time, I just select some members. So here, as you see in the design tab, we have steel design or RC design or mesh design for flat slab or raft foundation, and also you can do the cold form steel design. So today I will show you steel and cold form steel design. So we can actually set our various parameters, and you can even choose the design code, Eurocode, Singapore National Annex. So after we define all the parameters for design, we can simply go to steel code check. So this is the kinds of we can get from the table format. So if I click this arrow button, you can actually see all the design result in one glance. So there is a checking result. If it's passed or if it's failed, it will shows the NG with the red color, or it also shows the member number or combined ratio. Those information will be shown in this table result. And you can even see in the member, each or member by member, or you can also see in same properties result. So as I explained here, we have additional columns, torsion design, and after that we can just select the member, and we can even see the graphic type of the report. So in this graphic type of report, so there is design information and then member forces and design parameters and checking result. So including axial or bending, combined, torsion, and shear. Or sometimes we want to see the detailed calculation. So if I click this detail button, then it will show this kind of text format of calculation process sheet. So actually this summary report, all the result is from this detail report. So if you think if you see some doubtful result here in the summary report, you can simply go to detail report and check it. Because in here in detail report, program actually gives you all the design process. For example, here the classification of top flange or bottom flange, and then it also gives you some formulas with Eurocode section or clauses. So this is each step-by-step calculation process. So even you can match with your hand calculation all this process. So those two even those two report, you can actually save as PDF file format, or you can print it. So we can get the steel design result. And let's move on to the cold form steel. So in the slide I show here, so actually in cold form steel, we can design for this shape, this section size, these section types, lift channel cold form steel. So if you choose the cold form channel in section data, in Singapore standard continental steel size, then program actually run the design for this cold form steel. So let's see in the demonstration. So in the cold form steel design, we can also define the Eurocode Singapore National Annex, and then we can do the define all the details for this cold form steel design, and we can also click the cold form steel code check, similarly to steel design. So we also get this kind of table result, and we can also see the table result format, and we can also see the graphical format, and here design information, member forces, and checking result. And even the difference is this graphic report actually show the effective section diagram as well. So for cold form design for Eurocode, the effective section calculation is quite tedious, and this is the difference between the normal steel design and cold form steel design. Based on each width of the section, we need to calculate the effective width of each sections, and then corners, we also consider these corners, and program actually calculate all these effective section automatically and gives you the diagram as well. So similarly for detail report, we can also get the detailed calculation of this cold form steel. So as you see, the detailed calculation is quite long, and even it includes the calculation of the effective width. So check width to thickness ratio. So it actually consider all the effective sections for cold form steel. So now I will show you the dynamic report function in MIDAS Gen. So for the result, for report, we can go to tools and then we can click on generator button. So you can even open the new document if you want to work on this scratch, or you can open your own template of your calculation report. So let's say I open the template. Then program actually open the Microsoft Word file inside of your program. So here I have the template on my calculation report. So my template is like this, and then there's some introduction of my project, and then model description. So in this kind of report, we can actually add the screen captures. So for example, here in the model description, so we can actually change some colors as per different sections. Okay, so this is different section, and then we can change the viewpoint, and then we can save on the report image. And also in the result, for example, if I want to add these reaction forces, so we can make the reaction diagrams. So for the load combination 2, we can make the reaction forces. So we can also save this screen image for reactions. And also for the report, result tables, we can also save this result table. So we can see the force, reaction force, and then moment. We can directly click mouse right button, and we can save the tables together. And also if you want to see the deformations, so we can simply click mouse right button and we can save the image. Here, if you, in the report, if you use this reference DB, reference database, you can actually call the reference database from the previous project or other project. Which means even if you don't do this kind of mouse right button click and screen capture the image, you can actually call from previous project, and you can even use the saved defined image. So now I try to show you the from the scratch. So let's say here model description, I have the isometric view. So we can just drag and drop to my my report. And then you can also save your screen captures. And for example, if I want to add some reactions, and you can even use the reaction diagrams. And also you can even save your image for table. So if you have the table format of reaction, so you can also drag and drop to your report. And then we have the deformation contour. So there is deformation result as well. So actually we can make this kind of report based on inside of this MIDAS Gen program. And then there's some situation that we need to actually change our model. For example, here in this kind of structure, let's say after we finish all the report stuff, my contractor or some other our contractor or the architect, they want to change our model. So they want to delete this part. Then what we have to do, actually we need to change all the report data, including the diagrams also and analysis result, all the things we need to change based on this revised model. So what we have to do in MIDAS Gen, we can actually run the analysis again based on the revised model. So okay, I delete this part. So we can run the analysis. And after we run the analysis of this revised model again, we can simply go to the report again. So we can go to report again. So this is the previous model here, and then this is the revised model. So we can actually click on auto regeneration button. Then we can choose the component which we used for this report, and then we can click regenerate button. Then program actually automatically regenerate your report based on the revised model. So as you see in the process, program change all the captured image and the tables. And the impressive thing is it also saved the viewpoint and then configuration which we used for this screen capture. So as you see the reaction, I changed the viewpoint and then saved. So this will be also affected. And table result as well, and also deformations. So this function is very helpful to the engineer for the last minute change. Okay. So now I show you some unit member design using MIDAS Design Plus. I run the analysis again. So next is MIDAS Design Plus demonstration. So here I have Design Plus, and then in Design Plus we can choose Eurocode for RC and steel. So we can even choose steel section and material for Eurocode. So here in Eurocode version we can use the general column design or combined wall design, and there is isolated footing for mat and pile cap. And even we can design for bolt connection. So I show you today for foundation and connection. So actually this program we can simply use in 2D design environment. So there is an input box here, so you can input all the data, and then there is a figure, and this is a result box. So we can simply input the data and we can get the design result. So how we can use this Design Plus and MIDAS Gen. So for engineers, what we actually have to do is we run this kind of structural analysis in 3D analysis software like MIDAS Gen. And then we get these reaction forces, and with these reaction forces, we need to input in our spreadsheet, and then we need to run the design using Excel sheet or our own spreadsheet. Or if you have other this kind of design unimember design program, you need to actually input this loading by manually, right? So that is the problem of using without Design Plus. So how is like with Design Plus, how we can do it? So in Design Plus, we have the link option with MIDAS Gen. So using link option, we can connect this Design Plus program with MIDAS Gen. And then in MIDAS Gen, we can just select the position of the column footing where we want to design for footing, and then go back to Design Plus. We can select the footing and then go to Design Plus, and then there is also show the node that we actually selected in MIDAS Gen, and then we can simply import from MIDAS Gen to Design Plus. Then our program show you the components, 5 more components here. And this one, all the information from MIDAS Gen is linked with Design Plus. So concrete material or loading data for factored and then serviceability loading. So this loading also is already considered by this load combination in MIDAS Gen. So program actually choose the critical load combination for this loading. And then we can also change some other additional data if you want. And then we can simply check or design our footing in this data. So this is how we can use for this footing. We can also choose the pile cap footing. We can even change the number of quantity of pile or diameter or spaces. We can even change all those information. And here we have 5 components. So for example, if I want to do the design for this all 5 components, we can use also this member list option in member list. So member list provide the Excel table format of this design data. So using this member list, you can actually change all the input data here in table format. And the advantage is you can even use like Excel copy paste option for these many Excel cells. And if you have the analysis result, result from other software, you can also make the Excel format file, and you can directly copy from Excel to paste here, and you can use for design. And even we don't need to go one by one this component to design. We can just select all in here in member list, and we can do the design at once. Then program will give you the all result in at one click. And also it gives you the report, the detail report here. So it gives you the Microsoft Word form file in here also, or you can even get the report inside this program in case we don't have the Microsoft Word. So the format is same, PDF file format or Microsoft file format or inside this report. So we can check or design our footing, and then we can generating this detailed report. Then there's a diagram also, and generate information, material data, and there's a design force data, and also check data, calculation for all the foundation. And even like MIDAS Gen, program actually provide all the calculation details. So you can even see the formulas and values, which values has been used for design process. So this one you can even save as PDF file outside. And after we get the report of design, then we want to generate the drawings. So if we go to this here, drawing tab, what we have to do, we can just choose the footing in here, components, and then we can click create button. Then program create the drawings in here, this tab. And similarly, I show you the connection for using this design class. So we can move to steel. So here import connection. So the continental steel also we can use in this connection design. And there is also 5 types: fin plate, beam to beam, beam to column, and end plate, beam to beam, beam to column, and column bearing splice. So we can choose the type, and we can also use standalone like isolated footing, or if we have this MIDAS Gen model file, there is a steel connection part here. So we can just select the connection part, and then we go back to Design Plus, and we can simply click Import button. Then program will add the components here. So as you see here, we selected some column to column connection also, and column to beam connection. So program choose the connection type, so column to column connection, and also beam to column connection. So we can choose connected to web or flange also. So we can even change the the load force data also. We can connect it with Gen. So there's load combination, and also load has been connected with design MIDAS Gen. And if you want to change more detailed information, for example, number of bolts, we can also increase number of bolts or spacing of these bolts, and also the dimension of this plate or position. You can actually change all the information here. Okay, so for the report, as I show you in isolated footing, we can even see the detailed report with each step-by-step calculation process. And for generating drawings, we can also go to this drawing part, and you can simply choose steel bolt connection and click create button. So as you see here, there's various connection drawings here. And you can even modify this drawing inside of this Design Plus, the simple things. For example, you can draw the line or delete some part. You can simply change this drawing inside Design Plus, or you can also save as AutoCAD drawing file, DWG or DXF file. So if you save this file, it will automatically save as DWG, DXF file. so you can modify in AutoCAD. Okay, so this is about Design Plus. So now I will go back to presentation file. So the last thing is the general structures modeling in MIDAS engine. So today in the webinar we focused on MIDAS Gen program, but I just want to introduce you the MIDAS engine modeling types. So general structure, for example, this kind of structures. So this structure is RC and then is underground, the water, so it's for water, some water purpose, sorry. So here this is concrete circular shape, concrete, and then there is some two openings here, the round shape opening here in this direction and in this direction, and there's also ring beam in the middle point of RC. So these kind of structures, if you want to model and analyze in MIDAS Gen or other software, then imagine that how it's tedious in the modeling part and even the mesh system. So this one actually I modeled because I got some queries from Singapore user. So I modeled for them. So I actually record the video for this modeling. So I show you in the video. So this is MIDAS engine. So actually I just quickly skip and show you. So here we can just create the first guideline, and then we can generate the grid here. And then actually MIDAS engine provide the 3D grid system, so you can use this 3D grid system here. And we can extrude this grid line, reference line to generating the circular shape, circular pipe shape. And later we can actually use the grid line plane view. So as you see here, actually we can work on this vertical shape of the plane. So we can generating this opening shape here using this guideline as well. And then in MIDAS engine we have a special feature which called sweeps. This is actually like AutoCAD modeling feature. So if we have this kind of guideline, we can use this guideline to generating these shapes. So actually we can use this guideline to generating this shape. And later these two objects, we can actually intersect these two objects to generating the opening. So as you see in the process, I actually model to generating the opening. So now it has the opening here. So if we want to generate this kind of model in MIDAS Gen, so or other structures, other software, so we can generate this circular pipe shape, but the opening is quite tedious, and even for this mesh, automatic meshing, in MIDAS Gen we cannot mesh this curved shell. But using in MIDAS engine, actually program will automatically mesh all the all shape of the plate element. So we don't need to mesh before the analysis. Program will automatically mesh during the analysis, so we can directly model this kind of general structure or kinds of general structure using MIDAS engine. Then we can simply do the analysis and we get the result from MIDAS engine. So if you want to see some detailed process of this general structure, I can even share this video which I just show you. So you can directly write down the email to us. Then we can also share the video link together. So thank you for your time. So the session is just finished. So if you have any question, you can write down in the question box. Okay, I have one question that what types of the structures handled in MIDAS Gen? So as I explained in the first presentation, I showed some examples. So I show you again. So this one I included in the presentation. So if you have flat slab and RC frame and RC column walls or steel truss, steel frame in the one model, you can actually do in MIDAS Gen. Or this kind of frame, steel frame structures and flat slab with openings, or this kind of office building with the flat slab. And there's this is office tower, and then there is also steel truss roof here. So this kind of space steel truss we can also model in MIDAS Gen and do the analysis and design. And conventional building as well, or underground water tank. So we can actually apply the earth pressure load on this plate element, and then we can analyze by the program. And pile with the structure with the pile, or pile cap modeling, and RC frame structure, and castellated beam. So this one we can mesh and then we can analyze. And then chimney. And if you see this kind of plan, there's a small angles, different angles in the plan. So sometimes people like to use the grid line for modeling this kind of plan. But if you imagine that if you want to generate the grid for these small angles, many small angles and many different dimension, then it's quite tedious to do work on the grid system, grid modeling system. So in MIDAS, we can also use some MIDAS the modeling features. So this kind of modeling we can easily handle in MIDAS Gen. So this is spatial structures. So with two connecting connecting bridge. And this is actually Singapore application. So this is HDB. So we can even do the design for this kind of structures. And this is more structures. Also for the RC lamp structure type, we can even model easily in MIDAS Gen. and also steel structure with steel truss roof here. And this is big panel with the steel truss members and normal RC frame building. And this is very irregular shape using this steel with RC together. So even many projects of this kind of worldwide project already handled by the MIDAS Gen already. And this one is kind of general structures which I just show you. This is simple shape, so you can actually model in MIDAS Gen. And even you can use MIDAS Engine for the more irregular shapes. This is crane girder, so using the truss crane part here. And this is also steel structures with the steel truss roof here, and then steel column, truss column as well. Also steel storage truss structure. This is actually from the Malaysia. So this one is mainly handled for design for seismic action. So in Malaysia, in Kota Kinabalu, there's one consultancy designed for this detailed seismic analysis for this structure. So we can handle in MIDAS Gen. Okay, so these are the types of we can handle in MIDAS Gen. So because we passed a lot of time, so we will share the video if you write down the email to us, okay? So and then if you have any questions, you can simply write down the question to us, then we will reply back to your question. Okay, so now I will close the section, thank you for watching the webinar, and see you again. Thank you.